Hey guys, we'll start here in about 2 minutes. Oh, I am recording this. Okay. Remind me. Okay, now recording this. So on the 12th, when we come back, and I think I told you guys this the other day, but they're asking that if you, no, I told this yesterday. So we're supposed to give you guys the option to go virtual. You can still go virtual. Third hour, I think I have about 20 kids in here in third hour. And that's about 2 per table. Some will have 1, but a lot of tables will have 2 students. Well, it's hard to get 6 feet. The table itself is about 6 feet long. So it's gonna be hard to get you 6 feet apart, as if 6 feet is some magical number. They just made that number up, I hate to tell you. 6 feet, and someone said, well, how far? I don't know, 6 feet. Well, then now that's the standard. Like we sit around with the ruler. Now there's a sig fig problem right there. They just kind of guesstimated 6 feet, and now people are getting, that's 6.2 feet. I don't think that, that's 5.9. I mean, come on, people. It was a guess. Anyway, so the point is that when you come in on Monday, if you're in class, it's going to be 2 to a table, and I'm supposed to stay 6 feet away from you guys. So I know we've been kind of violating that rule because you're coming up to me, you're asking me questions, which I like, but I'm not supposed to do that now, because if somebody shows up positive and I say, oh man, I talked to Carlos, or I talked to Logan, or Harrison asked me that question and we were like face to face, then, and Harrison, if I come up positive, then Harrison's got to go quarantine for 2 weeks. So they're trying to avoid that. I get that, which means that when you're in class, I can help you from a distance, which is, I don't know how it's going to work, because we tell you the truth, when we were here earlier, we weren't always at a distance. So that might be just crazy talk, but that's what their plan is right now. So when you come back, it's not going to be like, it's not even going to be as good as it was. And it wasn't that good. So you might want to consider virtual. Virtual kids will get the same experience, not in class, but, and if it's activities and it's outside and you want to show up for that, I'm not going to stop you. If we're outside, if we're just at 5 minutes, maybe not, but if we're outside for 30 minutes and you say, I want to drive by and do that, you can join us for those. Anyway, because we are going to be a little more jam-packed, especially second hour. We're going to be a little more jam-packed than we were. They give you the option to go virtual if you want. And you might ask them, well, can I go virtual for a week and see if I like it and then switch back to in-class? Maybe they'll have a grace period there. And you all might know more than I do. I'm always the last to know. All right, so then we're going to start packet 2 on the 13th. And I know, now look, this also shows the day of the test now. The test is the 20th of October. That is the final date. I cannot move it back any further. It was originally the 1st of October. Now it's the 20th. So part of the reason is it was going to be the 15th, but then the PSAT, I want you all to not, those that are juniors, I think juniors take it on the 14th. I want you all not to worry about physics. I want you to be concentrating on the PSAT. So, so that's why I pushed it back till the 20th. Now you do have take-home tests due, but you'll also turn in on the 20th, you'll turn in your packet. Now the packet, all 8 pages, you go, well, I've already submitted 1.2, I submitted 1.4, I submitted 1.6. You're going to still turn those in. And this is a chance where if you get a 0 on it when you submitted it, like you never submitted it, but now you go back and do it finally, you can still get half credit. You can still get a 10 out of 20 on it if you do it, see what I'm saying? If you do it in the packet. So it's like your last chance. You'll also train your notes. So any notes, you'll take some notes today. Any notes you take will get stapled to the back, or else you'll have your notes in a notebook, and then you'll stick the packet in the notebook and you'll turn them both in. What else we got? Looks like we have our first Flashback Friday. That's good, on the 16th. That's a little 6-7 minutes of fun. And we have our first Joke Monday on the 19th. Well, that's good. Finally. Okay. And the big ACT, it looks like, is the 24th. You probably already know about that. So I got this off, I got the template off last year, and this is what a typical calendar looks like. I mean, normally we are doing all kinds of stuff. We got rocketry, and we got robotics, and we're doing Blue Days, and we're doing Stella Nova, and we're doing all this stuff. But there's Annie. We did Annie as a musical, you know. That's normal school. We did Facebook Lives, and we still do that, I suppose. But now we're doing Zoom, so that's what it used to look like. But I will fill in ours. Right now it's pretty bare, but I'll fill it in with due dates and things like that. So questions on the October coming up. This will grow. It'll get more user-friendly. You should be able to zoom in and see more stuff. All right. So I already talked about that. The key, I'll post the key to take home test 1A. I can't require it because you're sitting at home, it's what you do, but you really need, you have the paper copy with you. I will have a key. You turn it in, and maybe you got a perfect 75 out of 75. It doesn't mean you're right on all the problems. You're right on the problems I spot checked, but you're not necessarily right on all of them. So I expect you to check the key. Okay. So check the key on take home test 1A. And that key is posted today, probably by 6 p.m. A lot of things do it. I got to have these things done by 6 p.m. today. Okay. There's the key to 1.6. That was due last night at midnight. And I noticed that it was due at 11:59. I noticed a lot of students start turning in at 11. But then I watch them. I see when you submit it. And a lot of people submitted it at 12:04, 12:05, 12:07. Said, oh, man, you lost. Now you're late. But it's only 1 point off. It's only 5% off. Even today, if you turn it in right now, you can still get a 19 out of 20 on it, okay? So still turn it in. The key will be posted maybe tomorrow, I don't know. Eventually, the key's posted. We went over it all. If you watch the old, we went over a lot of this. We went over it yesterday. That's not a recording, though. But there's 10, 11. There's 12. We went over 12 yesterday in our office hours. Okay, now we're ready for today's physics. First thing I want to do is I want you in your notes, draw this little table and maybe make it a fourth of a page, make it a big table. And then we'll add to this later, but this is linear world versus circular world. So draw this out. I'll give you a minute to write it out, and then let's go over it. Just as a wrap up, every packet will probably have a little bit about linear world and circular world, like it'll have a little bit of circular world. I think circular world's about 5% of the class only, because that's more AP Physics. In AP Physics, the entire second semester is circular world. So that's why I want to keep giving you previews of it. So when he's talking about thetas and alphas and torques and taus and all kinds of stuff, you can go, oh yeah, I know what that means anyway. All right, so for linear world, we have delta. Okay, we have delta x or x. We have delta x, delta y, delta z, and then you can put these together. When you're sticking these together, we have delta s. It's some combination of those, all right? But in circular world, we just have delta, I'll make that black. We have delta theta. And that's it. That's how you measure, quote, distance. That's how it's all about how far have you gone around the circle. There was a movie called, it's a great movie called Midnight Express. And part of that movie is they're in an insane asylum, but they walk around this circle. That's all they do. Everybody walks around the circle all day. So it's like circular world. So they could talk about where are you? Well, I'm at pi. Where are you at? Oh, I'm at 2 pi. Well, okay, so you're furthest away. Pi and 2 pi are as far away as they can get, right? 0 and 2 pi are in the same place. So it just keeps repeating itself. Okay, and then we have, in linear world, we have velocity, and in circular world, we have omega, right? And that's a baby's bottom. And then in linear world, we have, for equations, we have like delta x equals v times t. We have the red equation. And in circular world, we have our newfound delta theta equals omega times t. And that comes, yeah, so it's omega being velocity, so that makes sense. So those are like linear versus circular. Now we have a couple of bridge equations that link up the two worlds. One is for delta S, and this comes from the definition of a radian. So let's go back and do this again. Sketch it out. For a pizza slice here, there's my arc length, so my delta S. And then I have, this is delta theta, the angle, and this is R. I guess R is kind of both worlds. R is the link between the two. And so we said that delta theta, by definition of a radian, delta theta is delta S over R. So a bridge equation is delta S equals R times delta theta. Good. The other one we did, we've been doing some, and that is V, linear velocity, equals R omega. So those are the two, so far, the two bridge equations. And we'll have a lot more. F equals ma for linear world. Torque equals I alpha for circular world. Little p equals mv in linear world. L equals I omega in circular world. So there's all these compared equations. All right, if we're good with that, let's keep going. Sorry, Brennan, I didn't see it. You said my submission for the take-home test was too blurry. Yeah. So some of you, you turned it in like you took a picture, but I couldn't read your submission. So and so he's asking, well, wait a minute now. So now I just finally saw that, and now I'm going to turn it back in, and now I'm going to be counted for being late. No, the thing is, Canvas will count it late automatically, so you might have to remind me. But oh, okay. So Brendan, and this goes to other people too. When you turn it back in the notes, there's little comments there. Make sure maybe all caps. You comment that you tell what you just wrote, okay? Say, hey, I'm turning this in because it was too blurry. Please take off the penalty, okay? I could see a student scam me on that. Just turn in a blurry test and then wait till the key's posted, then turn in the correct test. Nobody's that devious, right? You guys are too young to be that devious. You got to become old and a politician to start that kind of Mitch McConnell kind of deviousness. Okay. Sorry, no politics. I'm sorry, that's my bad. So now let's get out 1.7. 1.7. Now 1.7, 1 through 20 is just like we've always done, just like we did on whatever it was, 1.3 or whatever it was. Now, you're not going to submit this on Canvas. It doesn't mean you're not going to submit it. You're going to give me that paper copy on October 20th. Could you wait till October 19th, the evening of, and try and wildly, with sweat pouring off your forehead, do it? Yes. That would be really dumb because you got a lot of stuff. You got to get your packet together. You got to get your notes together. You got to study for the test. That's the time your little brother's going to freak out and the whole family has to deal with it. So something weird's going to happen that night. So don't wait till the night before. But you theoretically could. I'm not suggesting it. I think to keep up, you should have it done today. So 1 through 20 is just review. We've done it. I'll post a key, and yes, you know what? I'm going to post a key to this before you turn it in. So I certainly expect you to check the key. The key might not be posted till the test the 20th. The key might not be posted till the 18th or something, the 17th. But the key will be posted. I'd like it to be perfect. But on the test, you're going to get killed if you don't know. You know, the test is 300 points. So maybe you get 20 measly points for turning it in, then you'll lose 50 because of the daggone test. So, you know what I'm saying? So you're going to have to know it. But what I want to look at is this. I want to look at the new stuff on here, which is 21 through 25. And that's this notion of a better way to write something, or a better way to say something. Like if you ask me, how far do I got to go on I-35 to get to the Warren Theater? Like you're trying to figure out when you got to leave Norman. And I tell you, they say, how far is it? And I say that it's 440. I looked it up. I mean, I did the calculation. It's 443,000 inches. So I tell you, well, you drive 443,000 inches north on I-35, and then you'll be at about the Warren Theater. Well, I chose a poor unit. I should have said you go about 7 miles north on I-35, and then you're at the Warren Theater. So it makes sense in English. Like we try and choose the correct, like if we're talking about how much I weigh, I don't give my answer in ounces. I give it to you in pounds, right? I mean, it's just common courtesy. But yet students all the time use the wrong units in metrics, like this. This is the wrong unit. Kilometers was a poor unit to use. Micrometers here, in this case, was a poor unit to use. So the question is, give me a better unit, all right? So to do these better way to write problems, and this gives a lot of students problems here, but you go back up to your power line, and you're going to think through the power line. So look, I have a slide and help video on this. We're going to watch the first part of it. So I got to share a different screen. Let me stop sharing this one, and I will share a different one. Got to get faster at this. Okay, share that. All right, move this out the way, and let's full screen it. Can you guys, what are you guys seeing on your screen? I can't see your comments, so.
I can see.
Can you see it?
Yeah, I can.
All right, so you see the problem on YouTube. Let's watch together. This is me working a problem, and the problem here is, what is a better way to write 7.9 times 10 to the negative 7th kilograms? So it's a really small, like I'm trying to weigh a flea, a little flea. I want to see how much this little flea weighs. And I'm using kilograms, which is the unit I should use for people. Okay, so I chose the wrong unit. But let's think, what's a better unit to use? So now let's go through, and this shows my thought process. And I'll have this help video available to you. It's already available to you. I think it's in the introduction on maybe it is, on 1.7. So these are like, and it's also on Facebook. These are like grammar exercises for communicating physics. Since we're dealing with such small and large numbers sometimes, you need to talk in terms of, picometers sometimes. Sometimes you talk in terms of gigameters. All right, so the question is, which is the better one to do for this one? And so here's how my mind works when I'm trying to work through this. All right, so the first thing you do is you think of the problem in terms of a section of the power line. Like, where am I at on the power line? So here, for this one, I'm up here at kilograms, which is 10 to the third, but this tells me to move 7 powers to the left, 7 powers down. So there's 3 powers down, there's 6 powers down, 7 powers, okay? Keep going, and you guys, you can't ask your question in the comments here. You got to turn on your mic because I can't see the comments. So, so then notice I moved 7 powers down to the left. So that puts me at 10 to the negative fourth. Okay, everybody see that? Oh, I can see you. I take it back. I can see your faces over here. All right, so let's keep going. I'm on different screens though. All right, so now what do I do? Now I'm kind of figure out how to say it. So now we have a number that's somewhere between micrograms and milligrams, right? So which one do you choose is the question. Okay, now the number is 2 powers of 10 greater than a microgram, and it's 1 power of 10 less than a milligram. So how do I say it? It turns out, I'll let you say it either way, but I don't like decimals. Like if you say, how far is it from here to the library? I'm going to say it's about 40 meters. But I don't want to say, meters and kilometers are kind of between each other. But I don't want to say it's 0.04 kilometers to the library. If we're asking how far it is to Starbucks or to Stellar Nova's, I might say it's a half a kilometer. That's okay. But if I'm asking for how far to go to Norman High Library, I don't say 0.04 kilometers. I say 40 meters. Walk 40 meters down the hall and you'll be there. Okay, I guess. All right, so let's keep going. So here back on this screen, I got a pause built in so you can think about it. Here we go. So now I write it. I'm going to write it as, you could write it as 790 micrograms, or you can write it as 0.790 milligrams. But I'll take either one. But my preference, like I just said, is not to use decimals. My preference is to talk the way people normally talk. We don't normally talk that way. Like someone could say, well, how far is it to Dallas? And you could say, well, it's 1.8 times 10 to the second miles to Dallas. And you're correct. But normally you would say, well, it's 180 miles to Dallas. You know what I'm saying? Okay. So this allows us not to have to do a scientific notation. Okay, so there's another one on here, but I'll let you watch that at your leisure. I'm gonna, I had a professor in college that always said that. You can do this at your leisure. And I said, I never have any leisure time. I have 2 jobs and I'm got a crazy girlfriend and then I'm trying to do 15 hours of engineering. There's no time, there's no leisure time. All right, so I'm stop that sharing. And now let me share back on the other screen. At your leisure. There we go. Okay. So that's how let's do one of these together. How about that? Let's work one together. Get that off there. So how about we do 24? Let's do 24. No. Yeah. Yeah, 24. So let's do this one here. I'll blow it up. I'll give you a minute to think about it. You try number 24. It says, how are you going to write? What's a better way to write 3 points? It's a really big number in a really little unit. if you're having to write these, maybe you're an MKS and the teacher said, or the company said, you got to keep everything in terms of meters, kilograms, seconds, then you have no choice. But if I'm writing a paper on astronomy, I'm not going to give the distance between the Earth and the Moon in terms of picometers. I'll get laughed out of the conference. So I got to come up with a better way. This is like trying to give me a distance between here and Dallas, but I'm doing it in picometers. Okay, so hopefully you've tried it. Let's go up to the power line. And we're at, let me move this out the way here, sorry. And we're at picometers. Okay, so I circle it. And I'm gonna go 16 bigger. Well, I jumped 16, it's like a game, right? I jumped 16 places. And that puts me at 10 to the fourth, which I land right here, 10 to the fourth. Negative 12 plus 16 is 4, so 10 to the fourth. Well, that puts me between kilometers and megameters, but I see that I'm 10 bigger than a kilometer. So that means that my answer is not 3.52, it's 10 times bigger than that. So it's 35.2 kilometers. So that's like the distance between here and Purcell, or here in Oklahoma City. Penn Square Mall, let's say. So giving that distance between here and Penn Square Mall in picometers is ridiculous. Yet students do this kind of stuff all the time in metrics. Okay, questions, we're about to move on. We're about to move on to something, we're about to move on to the hardest worksheet of the year. And for some students, this sheet we're about to do is the hardest worksheet of the entire year. Keep going.
Could we do another one? Just
all right. Let's try another one. Let's go with the one that go negative, okay? So let's erase this and let's go with the next one. Let's do 3.52 times 10 to the negative 8. And by the way, there'll be some more of these on the next take-home test. We'll do some more practice there. Let's try this one. 3.52 times 10 to the negative 8 terahertz. So hertz is a frequency, like how fast something goes like this, back and forth, like a hummingbird flapping its wings. You measure that, it comes out as a sound. Hummingbirds make sounds. Whenever it flies by, you hear it. Things that move, a fly, that's hertz, right? Because the fly's flapping its wings. And so you pick up the frequency, a very high frequency. So those are in terms of hertz. Well, here we have a very small number with a very large unit. Bad idea. So we got to match the unit with the number. So we're at terahertz. Yeah, okay, so tera. Erase that. So we're up here at terahertz. Whether it's terahertz or teragrams, that's the cool thing about metrics. You can apply the prefixes to everything. You can't do that in America. Everything has its own, mass is in terms of slugs, which is bizarre. Hertz is finally hertz, thank goodness, in America. We didn't screw that one up, but pretty much every other unit's screwed up. And because we put flags in the back of our pickups and drive around like a bunch of idiots, we don't do metrics, because that's French. So anyway, so we do talk about hertz. So we have terahertz, and we got 10 to the negative 8. So I'm at tera. I'm going to drop 8 slots. So voila, surprisingly, I dropped all the way down to where I was before. I dropped down, what am I saying? What is it? Oh, 8. Okay, so I dropped down 8, which puts me at 10 to the 4th. Oh, sorry, 10 to the 4th. Boom, here. And once again, I'm back where I was. I'm at 10 to the fourth. So I didn't mean for that to happen, but coincidentally. So, so that puts me at 10 more than a kilohertz. So I could answer the question two ways. I could say 3.52 times 10 to the first kilohertz, or I could just say 35.2 kilohertz. Okay. Now, kilohertz is AM radio. So you, on your dial, you can turn to 35.2 maybe and pick up a station. Okay. Megahertz is FM, kilohertz is AM. Now, let's go on to the next thing. Did that. Oh, and I have this sheet for you. This will be on the Facebook group today. Sorry about that. This will be on the Facebook group today. I don't know, eventually, this will be in Unit 3. And in Unit 3 will be a place where I'll put equations as we collect them. I'm starting to get enough now for 1 page worth of equations. So I'll put those in Unit 3 in the Facebook group. This is going to go to about 25 pages. So I don't think I have enough room on Canvas to put 25 PDFs. I'm already at a third of my space. So maybe I'll start it there, but I have plenty of room on Facebook. So on Unit 3 of Facebook, you'll see this. It says side 5, and I mean, there are 4 sides before this, and I'll put some of those too, okay? All right, so ready to go to something new now. Here we go. Not totally new, it's 2D motion and on the front, and it's circular motion on the back. And so once again, you're not going to submit this through Canvas. This is worth a lot of points, but you'll submit it by paper. Okay. So we're going to work together. Let's go to number 1. Oh, it's the back. The back will do together. Most of this is done in class. The only one that's going to be due for homework, this is next week's homework. Your homework for today is 1.7. So I wouldn't even worry about this. This is next week's homework. Number 1. But we're going to work, that's easier compared, it's not easy, but compared to number 2, it's easy. It's easier. So let's go ahead and work number 2. This is what we're doing in class. So this will be in class. Don't worry about this for home. You can certainly try it. You can play around with it, but we're going to work on it at home and in here. Okay, so let's read the problem here. Drew intercepts the ball at the goal line and Drew was a physics student and a football player for Norman High. And he runs at a speed of 4 yards per second at an angle of 45 degrees for 6 seconds. Then he veers. Now, veer means you slightly change angles. He veers 15 degrees, like he jukes somebody. He veers 15 degrees to the left and runs at the same speed for an additional 7 seconds. So plot the 3 graphs that show his run, show how far he got before he got tackled. And this might be something, this might be some diagnostics. If you ever seen the movie, it's about the Oakland A's, Moneyball. You ever seen the movie Moneyball? Jonah Hill, I think is his name. He comes in, Brad Pitt's like the guy, the manager or something, and Jonah Hill comes in, and his job, he comes in and he technically looks through statistics of every player, and it's the first time they ever started doing that. And so it's really cool, really good book by Michael Lewis, but it's a really good movie. But what I'm doing is I'm going through on this football player, and I'm using physics to help the coach and help the player diagnose his run. And maybe they're sophisticated enough, with the Dallas Cowboys or something, that they go look and they say, look, here's what you did. These 3 graphs show your return of that, or interception, shows your return of the interception. And here's what you should have done, okay? But here's what you did. So that's kind of what we're saying here. We're breaking down But the thing is, why do I need 3 graphs to plot one run? Why not just, this is, okay, so this graph is X versus Z. You say, well, why didn't you make it X versus Y? You may have 2 questions here. First off, you ask, why is X on the vertical axis? Isn't that where we're supposed to do Y? No, not. That's just the way they do it in math class. It's not, math is not real life. That's something you have to learn. That math is, they live in some kind of ivory tower. I mean, I love mathematicians, but that's not how the real world works. Physics is like street math. I mean, we actually use it. So in real life, X may be the vertical, and why would I pick Z for the horizontal, the east-west sort of thing, the sideways movement of Drew? Because sometimes you plot 3 dimensions versus time, and Drew might jump over somebody, leap over a defender, and in that case, he would be in the Y direction. So I'm saying that the Y direction in this particular case, I'm saying the Y direction is up, down. X is north, south. Assume most stadiums are north, south, although I just realized Collins Field isn't. But like Owen Field, most football stadiums are built north, south, so the player's not looking to the sun. Except Norman High and OSU. Pretty much everybody else is north, south. So, so my X is my north, south. My Z is my east, west. So this is like north, south, west over here, and east over here, okay? So I'm looking down, like from the press box, looking down on the field, okay? Like Skycam. So you're measuring where he is. Well, okay, so I get that. I get the XY, the XZ and all that. I mean, I guess you do, right? Unless you're asking questions. Sorry, my chat box got destroyed. Logan's saying if it landed on 3, oh, Logan asked a question a long time ago. If it landed on 3, would it be? Yes. If it landed on, back on the metrics, Logan said if it landed on 10 to the third, then you would just say 3.52 kilohertz. You are correct. Yeah, 3.52. Yeah. Okay, so back to this. So XZ is looking down at Drew as he's running. And then we have these other 2 graphs, because notice that on this graph right here, on this graph, there's no time. I don't know how long it took him. I don't know whether he's walking or crawling or running. I don't know. So that's why this graph I circled in red is not good enough. I need to have, in addition, I need to have X versus T and Z versus T. You see, you go, well, wait a minute. Why don't we just plot them all on one graph? Well, that's going to require a 3-dimensional graph. It's going to require X, Y, X, Z, and T. So at any given point, he's at a X position, he's at a Z position, and he's at a time position. So it almost has to be an animation, you know? It could be a 2D animation. That would work. So if you want to make one, I'm going to give you some bonus for that. I'll give you points. That'd be a project. If you want to make that your project and you want to track out where Drew is through time, little dots, and then like stop animation, and then show me. That's another way of doing it. But because you don't turn in your iPad, we have to turn in paper, 2-dimensional paper. Now, maybe we can do 3 dimensions one day, like in 2028 or something. But right now we have to do 3 graphs to represent one motion, or 2-dimensional motion. And later on, like in real life, like if you're an engineer, or say you're an aerospace engineer, you're looking at an F-16 fighter or F-22 or something, you're saying, well, where was that at this point? Well, now you're looking at it where it is X, Y, and Z and time. So you're graphing 4 dimensions. AutoCAD, you know, you're watching it, but you're doing 4 dimensions through time. As you're animating it, that's your time axis. Okay, I'm down to a few minutes here. So let's get started. So he's going 45 degrees. Okay, so I plot this. I'm going to plot 45 degrees. And nice, it's a 1-to-1 ratio on this. So I plot 45 degrees, and I'll go blue, I guess. Oh, first I got to do this. I do a dashed line. And this is called, I'm almost done here for today. Like I say, we'll continue to work on this tomorrow. Next week. This is called a, carve out some space here. This is called a line of action. Now, this is used all the time in physics, a line of action. And that means that I know somewhere along that line, I'm going to put my, in this case, displacement. I don't know where, but we use line of action all the time when it comes to torque. I'm putting a torque on something. Well, where's my line of action? You know, if I'm looking at something rotating, where's my line of action? If I'm looking at energy, okay, what's my line of action? If I'm putting a hammer to a nail, where's my, so line of action is a big concept in physics. So there's your first line of action. Okay, I've only got a few minutes. So we got to plot he knows he goes 45 degrees, but the question is, how long do I make that line? So we go back and look at it. We say, okay, he went 4 yards per second, 45 degrees for 6 seconds. Well, if you go 4 yards a second for 6 seconds, how far do you go?
24 yards.
Or 24 yards. So I got to make this line 24 yards long. But wait a minute, I don't see how to do that. I mean, what you can do is you can take a piece of paper on one of the axes and you can measure out there 24 and then turn the paper so that it's now at an angle and along your line of action and then draw 24. That's okay. But I can't do that. It doesn't work on mine. So I have to do this way. I have to make it, okay, this is the last thing we'll do. I'll draw this 24 and I'll show you how I got it. Okay. I've already done this, so I know where it's supposed to end up. It ends up there. That is 24 yards. And how would I possibly know that? I could have taken that green arrow and run it on the Z-axis and then just tilted it like a piece of paper. But here's how I did it. Last thing. Here's how I did it. This is, whoa. It's never happened before. And this, whoa. Okay. I'm easy draw. It's having a problem here. Starting to go crazy. Okay, this is 17 yards. And this is 17 yards. Now, how did I possibly know that? Last thing before we go, how did I know that? Anybody got an idea?
Pythagorean theorem.
You would think, and you know what? You could pull it off because it's 45 degrees. But normally it's SOHCAHTOA. You guys heard of SOHCAHTOA, right? Because you gave your thumbs up the other day. Normally, I have each one of these lined up. So this is 17, and this is a nicer view. This is 17. Normally, you couldn't do that because normally it doesn't work out that nicely. But SOHCAHTOA is the reason. Here we go. Last thing, 24. I'll give you this. 24 cosine 45 is 17. 24 sine 45 is 17. You can prove me right on that one. Don't worry about it. What we're going to do is just don't give this a second thought. We're going to worry about this next week. But we're going to go through all these slides. See, watch. I'll do it quick. Boom, 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 until we finish, all right? But we'll get to that. That's more Monday. Now, here's your to-do list. You need to take on test 1B, okay? That'll be printed off. You don't have to do it today. You can come by my house anytime. Finish sheet 1.7. That's not due until October the 20th, but I would work on it, get it done, get it out of the way. And then any late work you haven't submitted yet, do that. Okay, I'm now over my, oh, what are we talking about? I still got time. Sorry, that was a false alarm. I'm gonna go another 4 or 5 minutes, okay? I'll go 4 more minutes, sorry. I know I gave you false hope. Okay, let's do this. So that's, I thought we ended at 11:30. We'll end at 4 more minutes, okay? Sorry, I'm an idiot. I had a Russian student named Constantine. Constantine ended up being probably, he's out in LA, but anyway, I'll tell you the story of Constantine. I don't have time to tell you Constantine's story right now. His favorite phrase was, "This is idiotic." All right, so look at what I have right here. And let's go back. I rushed through that. Let's go back that a little bit for a second. So in the time we have, let's just drop my thing. Let's just talk about this. So right triangle trig. So cosine, okay. Remember that SOHCAHTOA. Come on, man. All right. SOHCAHTOA. There are 4 of these questions. There's 4 trig questions in the ACT. 2 of them are SOHCAHTOA. So remember that sine is opposite over hypotenuse, et cetera, et cetera. So the sine of 45 would be the opposite, which would be my, if this is delta S1, let's say, that would be my delta S1, oh, no, hold on. That would be delta S1 sub X over 24 yards. Because 24 yards is my hypotenuse. Cosine of 45 would be delta S1 Z over 24 yards. Because it's always, remember, it's opposite over hypotenuse, adjacent over hypotenuse. So when you do 24 times sine 45, that gives you 17 to 2 siggies. So this is 17 yards. This is 17 yards. So when he intercepted the pass, before he veered, before he juked that guy, he got to the 17-yard line. Like, that's really all you care about. All the coach cares about is what yard line did you get to. All of this stuff here, all of the Z was a waste, according to coach. It's a waste. It's all about my coach in 6th grade. I was a running back and I was terrible. I mean, I was fast, but I was dumb as a bag of rocks. And I didn't know you're supposed to run. I knew you're supposed to run upfield, but I always tried to hit the corner. So my coach would always yell at me. He would say, "Askey, north, south, north, south." I had no idea what he was talking about. But I found out from my dad, he was a football player back in college, said north-south means you're running upfield, not east-west. So the coach wants you to run upfield. So this is north-south running. This right here. This is north-south running. This is east-west running. East-west running, no good. You don't get any bang for your buck. Okay. So that probably made it worse, but we'll continue on from there on Monday. I hesitated even to give you this worksheet because it's hard, but I wanted you to see that you do have to break down motion into all these different, anyway. So I'm gonna turn off that sharing, and any questions before, we still got 4 minutes, so before we officially have to end. Any questions from anybody before I'm gonna turn recording off, I guess.
So could we